I'm Orpheus Praxis. Welcome to the channel where modern physics gains a new sense of wholeness. Today we're going to explore why the cosmological constant, introduced by Albert Einstein, may not be necessary after all. When Einstein added L to the equations of general relativity, he did so to preserve a static universe. Later, with the discovery of cosmic expansion, he famously referred to it as his greatest blunder. Yet in the 1990s, with the observation of accelerated expansion, the cosmological constant returned, this time as an attempt to explain the mysterious concept of dark energy. But what if dark energy is not a mystery at all? What if it's not some external force, but a natural consequence of space itself? In the model we propose, the universe is not an infinite flat expanse. Instead, it is a finite, closed, three-dimensional sphere, compact and monochromatic in its fundamental spectrum. This isn't an abstraction, but a topologically consistent way for space to exist when the quantum nature of energy is taken into account. The expansion of this sphere is described by a wave function, psi, which is in constant interaction with energy density. And here's the key idea. This wave function creates pressure, a pressure of light directed inward, pressing against the structured vacuum of the sphere itself. In a closed space, this kind of pressure isn't an extra ingredient. It's a direct manifestation of geometry. It does not violate conservation of energy, because total energy remains constant. What increases is only the volume, and as volume grows, density falls, which is precisely what observers perceive as accelerated expansion. At the current stage of cosmic evolution, with a radius of roughly 13.8 billion light-years, this pressure of light is equivalent to about 78% of the total energy balance. In other words, it exactly matches the so-called dark energy being searched for in the vacuum, but here it emerges directly from the geometry and wave-based dynamics of space. As the universe continues to expand, this value asymptotically approaches 1. Why? Because in a closed system where no energy escapes, all behavior tends toward equilibrium, toward a full identity between energy and form. In the limit, the pressure of light becomes the entire dynamic. The cosmological constant becomes unnecessary, not because it's wrong, but because its function is already embedded in the topology itself. Now let's look a bit deeper into this dynamic. Before recombination, the moment when the universe became transparent to photons, the behavior of the sphere is governed by a wave function, psi t equals a L by L for t former 3 vid minus 3 ver 4 diner t curd, where phi is the golden ratio. During this phase, the radius grows fractally, RT equals F and T, with clearly defined discrete quantum levels of energy density. After recombination, the wave function takes a different form. A equals BE EHT. In the radius, begins to grow exponentially in the grow exponentially, R equal to R dot x T rec. This is the modern phase of expansion. In both regimes, total energy remains constant. E total equals 7.21 times 10 to the 69 joules. And the density is determined purely by geometry. Rho of t equals E total of V of t, where the volume V of t equals 4/3 by RT equals 3. So what appears as acceleration is simply the result of decreasing density in an expanding volume. The energy itself does not increase. What changes is how it is distributed. And the pressure that emerges from this distribution, that's the quantum equivalent of dark energy. This isn't a hypothesis, it's not a speculation. It's the logic of spatial structure itself. If we view space not as a passive stage, but as an active form with a wave-based internal architecture. And this leads us to a powerful conclusion. The cosmological constant L, originally introduced by Einstein as an artificial correction, turns out to be redundant. Not because it was mistaken, but because it becomes unnecessary once space is described not through abstract constants, but through a concrete quantum dynamic in a closed volume. Our model aligns with observable data, the anisotropy of the cosmic microwave background, Planck WMAP, the current value of energy density, today 7.74 times 10 mesemes joules per cubic meter, the discrete structure of galactic distribution, Gaia, JWST. In upcoming episodes, we'll dive into the detailed structure of the wave function psi of t, why the S3 topology is the only one consistent with quantum geometry, and how this model allows us to move beyond inflation, singularity, and external parameters. Subscribe to Orpheus Praxis. We don't chase theories. We return to the logic of space itself. We explore not speculation, but structure. See you soon.